And today we are going to talk about properties of integer in mathematics. So let's get started with our topic. First, we'll talk about the agendas, what we are going to discuss today. So introduction, the rules of sum and product, permutation and combination, the binomial theorem, then combination with repetition. So first, we'll go to the introduction part. An integer is a whole number that can be positive, negative, or zero, but not a fraction or a decimal. It's used in mathematics or computer science to represent the discrete values, typically within a defined range based on the system architecture. Integer types in computing can be categorized into signed or unsigned, determining whether they can represent negative values or not. In programming, integers are foundational data types, often used for counting, indexing, arithmetic operations. They have specific memory requirements, usually defined in bits, which influence their range and computation performance. So this is what integer. So we are going to talk about the rules of sum and products. So first of all, sum of integers. Four rules have been defined here. First is commutative property, associative property, identity property, and inverse property. So commutative property is a property, the order in which you can add integers and the result will not change. Like one example has been given, that is a plus b will be equal to b plus a. We can change their orders, it will remain same. Then associative property, the way you group the integers for addition does not change the result. Like example is a plus b plus c is outside the bracket. Now we'll shift the bracket to b plus c. So a plus bracket of b plus c. Both the answers will remain same. Identity property. Adding 0 to an integer does not change the value. Like example is a plus 0 will remain a only. So inverse property. For every integer, there is additive inverse. Additive inverse is what if a will be there, plus of negative of a will give you 0. So basically in this, you're going to get 0 as an answer. Now, product of integers. Some rules are here. Commutative property, same as previous. The order in which you multiply the integer does not change the result. Example, a into b will be equal to b into a. Associative property, the way you group the integer that will be multiplied and the result will remain the same. Example is a into b into c can be written as a into bracket will be shifting towards b into c. Now, identity property. Multiplying an integer by 1 does not change the value. There it was 0, here it is 1, and we are going to multiply it. It will remain same. A into 1 equals to A. Zero property. This is a new property. Multiply any integer by 0 results 0. So A into 0 equals to 0. Distributive property. Multiplying an integer by a sum is equivalent to multiplying the integer by each term in the sum and then adding the result. Means example is a into b plus c is there. Now we will distribute it. A into b plus a into c. So this is what the rules are. Now next topic is permutation combination. So what do you mean by permutation? Permutation refers to the arrangement of set of elements in a specific order given a set of n and n distinct element, a permutation considers a different order in which these elements can be arranged. Formula of permutation. For arranging R and R element out of n and n distinct elements, the number of permutation is given by P n comma R equals to n factorial bracket of n minus R factorial. So this is what the formula is. For example, you are taking, if you have a set of 3 elements, 1, 2, 3, there are 6 permutations to be arranged. So what are those? 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. So these are what the combinations will be. Now, moving to our next topic, that is combination. What do you mean by combination? Combination refers to a selection of subset of elements from a larger set without regard to the order. So, formula of combination is the number of combination set C, n and R, same, nr equals to n factorial into r factorial multiplied by n minus r whole factorial. So this is what the formula is. One example has been given. Given a set of 4 elements, 1, 2, 3, 4, the combinations for selecting 2 elements are 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. So this is what permutation and combination. Now we are going to learn about the binomial theorem. So statement of binomial theorem is as follows. Given integer a, b, and n, where n is non-negative integer, the binomial theorem states that a plus b into n sigma of k equals to 0 nk into ak into bn minus k a plus bn equals to 0. In this expression, the symbol nk and kn represents the binomial coefficient, which is the number of combination to choose k and k elements. Out of nn, it is calculated as follows, where n factorial and n factorial denotes the n factorial, the product of all the integers from n down to 1. So we are moving to our next topic, that is combination with repetition. So what does that mean? Combination with repetition or combination with replacement allows for the selection of elements from the set which the possibility of choosing the same element more than once. So you can choose one element more than once. The combination which repetitionally concept is essential in various contexts, especially when working on the set of integers. Formula of combination with repetition. So combination formula is C of n plus r minus 1 comma r equals to n plus r minus 1 r C n plus r minus 1 comma r nr plus r minus 1. So here one example is there, that is, consider a set of 3 distinct integer 1, 2, 3 and goal to choose the 2 elements without repetition allowed. The following example demonstrate the combination with repetition. So first one is choosing 1 twice, 1, 1, 1, 1. Choosing 1 once, 1, 2, 1, 2. Choosing 1 and 3, 1, 3, 1, 3. Choosing 2 twice, 2, 2, 2, 2. Choosing 2 and 3, 2, 3, 2, 3. And then lastly, choosing 3 twice, 3, 3, 3, 3. Applications of integer in context. Combination with repetition applies to various scenarios involving integers such as integer partitioning, combination problems, then statistical distribution. These are the three applications of integer constant. Then what are the summary? So by this video, we came to know that what do you mean by whole number, positive and negative, infinite set, then mathematical operations, discrete nature, then property and rules of sum and product. There are four major properties, that is commutative law, associative law, distributive law, and identity law. So, and then applications of mathematics. Integer is used in algebra and theoretical and combinational use. In computer science, we can use it in discrete value like indexing, then counting, etc. In engineering, used in digital design and processing control system. So for today, that's enough. And thank you for watching this video. Do like and subscribe my channel.